Welcome to The Explainer. Today, we're jumping into a word you've almost definitely heard thrown around, but what does it actually mean? It's kind of like the invisible force behind some of the smartest, coolest technology we use every single day. And to really get it, we're going to start by solving a little puzzle. So let's start here. What in the world is the connection between a surgical robot that performs operations with mind-blowing precision and the autofocus on your camera that snaps into clarity in a split second? I mean, on the surface, they seem like they're from completely different planets, right? Well, let's look at the clues. Okay, clue number one, industrial robots. You've seen these, the absolute workhorses of modern factories. They're welding, painting, and assembling things with a kind of strength and precision that's, well, it's totally superhuman. The key here is powerful, controlled physical motion. Clue number two, 3D printers. I mean, how cool are these? They take a file, a digital idea on a computer, and then layer by tiny layer, bring it into the real world as a solid object. See, it's a perfect marriage of mechanical parts moving exactly where they're told by electronics, all following a software script. And for our final clue, let's look up at the sky. Drones. Just think for a second what it takes for one of these things to just hover in place, right? It has to fight the wind, navigate around stuff, and keep a camera perfectly steady. It's this non-stop, high-speed balancing act between motors, little sensors, and a ton of software. So, you got it yet? What's the link? Well, the answer, the thing that ties all of these smart machines together, is mechatronics. This is it. This is the secret sauce, the design philosophy that makes every single one of these incredible devices actually work. So, what is it exactly? Well, mechatronics isn't just one thing. It's where several huge fields of engineering all smash together. It's the meeting point of mechanical engineering, electronics, computer control, and this big picture idea called systems thinking. And really, the most important thing to get is that it's not about any one of those parts. It's about how they all work together. It's about synergy. You know, the name itself is actually the biggest clue. It's literally a mashup of two words, mechanics and electronics. And that's a perfect way to think about it. The mechanical parts are like the body, the skeleton, the muscles, the parts that actually move and do things. But the electronics, that's the brain. That's what does the sensing, the thinking, and the controlling. Body and brains working as one. Okay, so if mechatronics is the recipe for a smart machine, what's actually in it? If we were to look at the blueprint, what are the core ingredients we'd need? So basically, every mechatronic system has these four essential parts. You've got your mechanical systems, the gears, the levers, the physical structure. Then you have the electronics, the sensors, the circuits, the tiny microcontrollers. Next up are the control systems, which are really just the smart algorithms that make sure it all does what it's supposed to do. And of course, the software that brings it all to life. But the real magic, the true heart of mechatronics, it's that little bit right in the middle, systems integration. That's the art, the incredible challenge of getting all these different fields to talk to each other and work together like a perfectly rehearsed orchestra. All right, enough with the theory. It's cool, but where does this stuff actually show up in our lives? Let's take a look at how mechatronics is all around you, probably in a lot of places you'd never even guess. And before we see the finished products, it's really cool to see how they come to be. It's not just a flash of genius. There's a process, a very logical path. It all starts with a problem that needs fixing. Then engineers dream up a concept, they pick out all the right mechanical and electronic parts, and they often build a digital version, a computer model, to see if it'll even work. Then comes that all-important integration step, putting it all together for real, before a whole lot of testing and tweaking to get it perfect. And the results of that process? They are everywhere. Think about the automotive world. That anti-lock braking system, your ABS, that keeps you from skidding, that's mechatronics. It senses the wheel speed, a computer decides what to do, and the mechanical brakes react. In medicine, we've already talked about those amazing surgical robots. And in aerospace, it's the absolute core of the flight control and navigation systems that keep planes, and yes, drones, safely in the air. So, what kind of person actually builds this stuff? Well, Because the field itself is a blend, the people have to be too. A mechatronics engineer has to be like a jack of all trades. They have to be comfortable with mechanical design, with circuit boards, and with writing code. But honestly, more than any one technical skill, the most important thing they have is just incredible problem-solving ability. So we've seen what mechatronics is, and we've seen where it is today. But what about tomorrow? Where is all of this integration and intelligence actually headed? And that really brings us to the biggest idea of all today. You have to understand that mechatronics isn't just about mixing different types of engineering together, it's a whole design philosophy. It's a fundamental shift in how we approach building things. The entire point is to create machines that are way smarter, more efficient, and more flexible than we could ever make by keeping those fields separate. And that, right there, is why the future is so unbelievably exciting. As we start cramming things like artificial intelligence and the Internet of Things into literally every device, the possibilities for mechatronics just explode. We're talking about robots that can learn on their own, factories that can run themselves, and technologies we can't even dream of yet. Thanks for joining us for this explainer. We'll leave you with this to chew on. As our whole world gets smarter, what brand new, jaw-dropping problems do you think this powerful way of thinking will solve next?